Hello everybody, today I'm going to introduce named entity recognition, a typical natural language processing task and topic. So it is a brief introduction of the essential concepts with some hands-on notebook and open source Python tools introduction. So what is named entity recognition? So it is also known as entity chunking, extraction, identification. It is a type of the task of detecting, locating, and classifying the key information, such as named entity, within the text into the predefined categories, such like persons, organizations, locations, date times, quantities, monetary values, percentage, and so on. There are many use cases for named entity recognition. So such like accelerating, speed up the HR processes, such like the CV screening and the fast candidate selection. Also boost customer support on the front end office. And also enhance the search engine recommend engine with recognized entities. Also reduce the healthcare workload by auto-extracting key information from lab reports. It can also speed up the search and insights retrieval from the big data of the papers, documents, blogs, posts for research and academic purpose and more. For example, the European Union's digital platform for cultural heritage, European, is using named entity recognition to make historical newspaper searchable, which is a very good purpose. Many advantages of using the named entity recognition. First of all, it is very easy and straightforward to use and start with. There are many open source libraries and out-of-box models available to use straight away, such like the Python TK pager, Spacey, Hugging Face Transformer, named entity recognizer, and also the Stanford University provides the NER in the Java. So we are going to try to look some actual examples and how to use all these open source libraries in the notebook in a minute. So if the out-of-box model cannot serve your purpose, you can always choose the option of transfer learning and training your own customized NER model. So for this purpose, you have to create your own entity categories and also labeled training test dataset to suit your specific task. So as we say in the data science, the more data, the merrier. So the more relevant training data and the more accurate the custom model you will get. So POS, part of speech, is a concept related to the named entity recognition. It is typically performed before the NER and the entity chunking. So what is the POS tagging? In linguistics, the part of speech tagging, also known as grammatical tagging, is the process of marking up a word in a text as corresponding to a particular part of speech based on both its definition and context. So a POS tag is a special label assigned to each token word in a text corpus to indicate the part of speech and often other grammatical categories such like tense, number, case. So POS tags are used in corpus search and text analysis tools and algorithms. For example, I want an early upgrade. I is a pronoun, want is a verb, the an is a determiner, early is the adjective, and upgrade is noun. So entity chunking is an NLP process of grouping small pieces of information into large units. So the resulted group of words are often called chunks. So the primary use case of entity chunking is making groups of non-phrases. So there is no predefined rules for entity chunking. So you can always DIY your own rules according to your specific needs. For example, in the notebook, I'm going to introduce how I'm going to define my own chunk pattern of a noun phrase, and then how I'm going to use it in the to generate the entity chunking and so on. So basically, there are 3 steps involved in this procedure. In step 1, you have to use the regular expression to define a chunk pattern that indicates how noun phrases should be detected and chunked. And in the step 2, you can create a chunk parser using the chunk pattern rules defined above. Then finally, in step 3, you apply the chunk parser to parse the part of speech text to retrieve the noun phrases. So we'll see the actual example in the Python notebook. So finally, the named entity recognition is about recognize a named entity. So it's a special type of the chunk extraction practice that use both entity tags and the chunk tags. So the common entity tags include such like the persons, organizations, locations, date, time, and so on, as we just mentioned. So in summary, a typical natural language processing workflow for generating the named entity like this. So at the beginning, you got some just raw unstructured text data, right? Then you have to tokenize it and generate the part of speech text. Then you apply the entity chunking to generate the chunks. And finally, you recognize the named entity out of it. Okay. And we'll go through this whole pipeline of the named entity generation in the hands-on notebook. There are also some useful reference and resources about the open source tools and the libraries we're using, and we're going to actually to introduce them and in a minute. Okay, so the first tool and open source library we're going to introduce for named entity recognition is Spacey. Spacey is an excellent and high-performing NLP library for Python. So it is a bit newer than NLTK or Sklearn, but this library specializes in providing an easy way to use deep learning for analyze text data. So there's some Spacey tutorial under 101 listed here. Also, the Textcy is a Python library which is built on top of Spacey for performing a variety of NLP tasks with the fundamentals such like tokenization, part of speech tagging, dependencies parsing, and so on. Also, I showed the GitHub repo here. First of all, you have to install the Spacey and its key components. Then you input the library, and then you load the Spacey's English tokenizer, tagger, parser, and NER and word vectors. Okay. And also here I just give some like the random the test samples to test the Spacey. So by the way, there are 2 options. You can represent a single long text string occupying the multiple lines in Python. So either using the backslash here, or in the second option, you can using the triple quotation marks. So you can using the easy way according to your personal preference. For me, I always like using the triple quotation marks because it's less effort. Okay, you can see after we actually see like the original text string is the Python string type, but once you put into the Spacey, it becomes the Spacey token document type here. Okay. So it's pretty easy to extract the noun phrases and the verbs using Spacey, just like one line code. Okay. So for in the Spacey, the noun chunks, and you can just print out all the noun phrases and also print out all the verbs here. So for our test sample, okay, you can see the Sebastian Chuang, self-driving cars, Google, few people, the company, him, I, you, very senior major American companies. All these, the noun phrases has been successfully, detected by Spacey. Also, the verbs like the start, work, drive, take, tell, shake, turn also has been detected. Okay, that's very nice. Also, as a extra bonus, also I show how to extract the verb phrases here using my DIY code. Okay, so for example, this is some like debugging reference to solve this kind of the problem. So basically, the text TC, the have used to this kind of the part of speech regular expression matches function, but it's deprecated. So we have to use another new function called the token underscore matches. Okay, so then you define some verb phrases pattern. So this is actually regular expression. So for example, this is any verb, any optional number of verb followed by any optional number of the other verb, and then followed by one or multiple verbs, and then followed by part. So after we define this verb phrase pattern, and we actually launch the uh, the part of speech, the parser to actually to generate the verb phrases using the Spacey, okay, and the taxi. You can see the writing, going to, come, play, guess. All this has been generated. That's very nice. Okay, so let's move to the next step, the extract named entities. Spacey actually is capable of recognizing the many named entities categories, such like a person, NOP, which is nationalities or religious or political groups, or organizations like the companies, agencies, institutes, or the GPE, the countries, cities, towns, states, or similar locations, or any other non-GPE locations, okay? And also the product, events, works, date time, money, quantities, and so on, okay? So it's quite a comprehensive list of the named entity categories the Spacey can recognize. Also, finding the named entities is very straightforward. Just one line code in Spacey. You just like to call this dot entities, the function, and you can, print out and get all the named entity recognized by the Spacey. So here we can see like the Sebastian Tron, Google, 2007 American Tron record early this week has been successfully detected, and also the entity class labels are correct, for the person, for the GPE, for the date, for the organizations, and so on. Okay, quite nice. Also, you can even visualize the named entities generated by the Spacey. Just call this library, okay, and the one line code. You can see the Spacey, the named entity recognition, zero-shot prediction result is quite impressive. So, except the Tron has been mislabeled as GPE, the geographic organizations. Other entities are correctly recognized. Okay, so on top of it, you can see this such kind of the data visualizations is very pretty to take a look at. Okay, so here also I do my own experiment. I actually create a homemade example and about how to use in Spacey named entity recognition to detect suspicious knife crime event reported in Twitter. So those days is so many tweets and messages, the posted by the huge amount of people in Twitter. And I'm just wondering if I'm capable of take advantage of the Twitter and the named entity recognition technique to detect some like the knife crime event reported by the people crowding information. Okay, so for this purpose, I building this chunk of code. So basically, my hypothesis is here. If a Twitter message contains both date, time, and location information, plus gun, knife keywords, it is likely, the report of the crime event. Okay, so this line, this chunk of code, and just like to make such kind of detection using the Spacey NER, the out-of-box model. Okay, so here I'm give some like the any like I just found some random tweet samples from Twitter, so like these samples and these samples and these three samples. Okay, so you can see for these samples, Costco Tory police cars knife crime all-time high in Brighton. Is it the major or London's fault? It is not predicted by the Spacey as like the crime event. Okay, so for this kind of things, sort the country at first, Brexit, knife crime, okay, blah blah. This is also no issue detected by the AI. But for this tweet, look at this. Burglar attempts in Beckton in the early hours on Friday, okay, 2020, this kind of date, the couple of guys try to use a big knife to get an entry from. So because this tweet mentions both the location and the date time information, and also the knife, the keyword has been mentioned. So our program is successfully, the detection. This is some likely the knife gun crime event. Okay, so this is quite nice. So I can easily to extend this kind of the program to add, for example, and I can using the Twitter APIs to actually to real-time monitoring the tweets video frame, the live like messaging streaming, and then I using the code to detect any the suspicious knife crime event in the real-time manner. So that could be very nice. Okay, so then the second open source library for name entity recognitions I'm going to introduce is NLTK. Okay, there's some tutorial, and also you just import the package NLTK, and then it's auto tokenize part of speech text and the chunks and expression parser and so on. So this is some like the another examples. First of all, we're using the NLTK to generate the part of speech. Okay, you can see this is the part of speech generated for this test samples. Okay, and you can see above, we got like the a list of the tuples containing the individual words in the sentence and they associated the part of speech text, such as the word POS tag. So for example, so we see the European is the adjective, authorities is the non-plural, Google is a proper noun, and the whole list of the NLTK part of speech abbreviation can be found here. So you can see here. So this is all the NLTK POS abbreviations, such like the DT stand for determiner, the FW stand for foreign word, and so on. Okay. So noun phrases generation. So now we are going to detect and chunk the noun phrases using a regular expression consisting of the rules that indicate how sentence should be chunked. So our the noun phrases chunk pattern consists of one rule that a noun phrase should be formed whenever the chunks finds an optional determiner DT followed by any number of adjectives JJ, and then one or multiple nouns NN. That is the pattern I defined here. Okay, so then we actually I apply this the pattern, and I create a chunk parser and test it on our test sample sentence. Okay, you can see I execute these three steps, and the result is actually some like the hierarchical tree structure of the sentence with the part of speech text generated. Okay. So above we can see like the noun phrases such as like the record, a record, Wednesday, the mobile phone market, the company, see, has been successfully passed, although the output is not as clean as that of the Spacey. Okay. Also, we can use in the switching to actually to realize the chunk passing result in a hierarchical tree structure. So first of all, you install the package, if not yet, and then you draw the POS, the tagging the result. So you can see the noun phrases European authorities has been detected, noun phrase Google detected, a record detected, Wednesday detected. Okay. The mobile phone market detected, another noun frame, the company, another noun frame, practice, another noun frame. Nice. Okay. So the IOB inside, outside, and the beginning text are slightly different from the POS part of speech text in terms of representing the chunk structures. So this format can denote the inside, outside, and beginning of a chunk. So it's very easy to generate the IOB text like this, just running the the line code, and you can see the European authorities or this kind of have the associated the IOB text. So the B-NP stands for the beginning of the noun phrases chunk, I-NP stands for the inside of the NP, O stands for the outside of the noun phrase. Okay. So then finally we are using the NLTK to generate the named entity. Okay. So we just like calling this function, the NE underscore chunk. So we can using the NLTK's pre-trained named entity chunk to recognize the named entities. The chunk actually as category labels such as like person, organization, and GPE locations and so on. Okay. So let's actually to use it. Okay, you can see call this function. Okay, and also before that you also have to call the tokenize the raw text and then generate the part of speech text. So this is our whole NLP working flow we just introduced in the PowerPoint slides. Okay, so now you can see it can generate the size and NLER, the text has been generated using the NLTK. So from above, you can see like the NLTK NE underscore chunk function retains an object of the NLTK tree type with S as its root tree label, and its some branches are either an object of the same tree type, that is tree GPE European JJ. Okay, so this is if it recognize it is a recognized named entity like the European with its category label just like the GPE and a one-dimension array containing a tuple of named entity part of speech tag like the European JJ stand for the adjective, or simply a tuple like authorities NS if it's not recognized as a named entity. Okay, so with this knowledge in mind, below I just define a utility functions to actually to filter out only the named entities from the NLTK result to give a clean display of all the named entities identified. Okay, so this is my code. This is just a simple like the simple line of code with the Python list comprehension and also with some conditional the filter because we only want to find the recognized named entities, which is like the NLTK tree type. Okay, so by this way you can see this my code nicely generates the two named entities belong to the GPE and the person categories. Okay, so also we are going to do some like-for-like comparison between the NLTK and the Spacey using the same test sample above. Okay, so this is our original the test sample. Okay, and the NLTK the result is this one. Okay, so the observations on the NLTK out-of-box the named entity recognizer is that it's actually not good enough. Actually, it's not accurate and quite few missing entities. The Google and the record are misrecognized as a person, but should be the organization, right? And the CUs are misrecognized as organization. Also, it fails to detect the dead times such like 2007 and earlier this week. The only thing it did better than Spacey is it correctly recognized the Tron as a person, but not the whole person name or the Sebastian Tron. Okay. Although it is just a single test sample, it's nothing close to a comprehensive conclusion, but you already can see a bit like the performance difference between the NLTK and the Spacey. Okay. The third open source library and the tools we are going to introduce is Hugging Face transformer-based named entity recognition. Okay, so the BERT, the bidirectional encoder representations from transformers, is a transformer-based artificial neural network architecture. Okay, that is about the deep learning architecture. So the BERT uses the encode part of the transformer to encode the semantic and the syntactic information in the word embedding, which makes it powerful to perform a variety of the NLP tasks, such like text classification, summarization, question answering, as well as named entity recognition, and so on. So Hugging Face provides easy access to many popular deep learning libraries, models, such like the BERT, DistillBERT, Roberta, and datasets to do all sorts of NLP tasks. So the Hugging Face NLER models can be found under the token classification sector here. And also, for example, you can select the bert-base-ner model here. You can also find the very useful Hugging Face transformer tutorials and the learning courses here. Okay, let's actually try it by ourselves. Okay, so first of all, you have to download and load the Hugging Face pre-trained tokenizer and the NER models. Here we just like download and load the bert-base-ner model. Okay, so and also you can just check out the web link above and also choosing any more powerful and the latest the named entity recognition models from Hugging Face. Okay, portfolio. Okay, now you define the pipeline, which is as NER pipeline, and this is our model and the tokenizer we are going to use, and then you supply some test text samples, and you actually to do the named entity recognition. Okay, so you can see here, so the Wolfgang my name is Wolfgang and I live in Berlin. So the named entity Wolfgang is correctly detected as a person, and Berlin is correctly detected as a location. Okay, nice. So again, let's do a like-for-like comparison using the same test sample as above here. So this is the Hugging Face bert-ner model's output is a bit like verbose. So here is some limitations and bias about this deep learning model. So this model is limited by its training dataset of the entity annotated news articles from a specific period of time. So this may not generalize well for all the use cases in the different domains. Okay, so you have to know the limitations and the potential bias before you actually using any AI models. That is actually very important. Also, we can see the model occasionally takes the subword tokens. Yeah, you can see in the above the RE and the code actually these two subword tokens for the whole word recode this company name has been actually been tagged by this transformer model as the entities. So for this reason you have to do some post processing of the result to actually to choose any like the useful the output. So here, we can just using the grouped entities, the equal to true, the option to actually to resemble them to get a, the good view. So this kind of the option command we can use. So by calling this, you can see the result is cleaner and better. Okay. The Sebastian Chuang person, Google organizations, American Chuang record. So the observation is here like a Hugging Face, the pre-trained bert-base-ner model performs well, managing to recognize the most named entities, although still detect the subword token like the THR, this is just like the part of the whole word. And also not able to detect the dead time entities such like 2007 like Spacey can do. Okay. Also for the if the out-of-box NER models are not good enough to solve your particular problem, so it is always possible to fine-tuning a pre-trained Hugging Face NER model with your own custom data set for your specific domain use case and scenarios. If you would like to go down to that route, okay, do check out this excellent Kaggle post on how to do the NER transfer learning. So I just show the reference to this notebook here as well. So a brief summary about this initial introduction about the named entity recognition. So it is a typical NLP task where many open source libraries, Python packages, and tools are available to use. And also in this initial assessment, we can see Spacey probably achieves the best zero-shot inference accuracy out of all the popular tools, whereas Transfer, the BERT model family, has great potential to explore, optimize, and transfer learn to achieve the state-of-the-art performance. Okay, that's great. Okay, and on the another side note, so for this kind of the homemade example, the how to using the Spacey, the name entity recognition to detect like the potential knife crime events in the. Also, I mentioned like it can be integrated into some end-to-end solution, such like using the Twitter, the streaming API to actually live, the monitor, all these kind of tweet messages and detect the crime events. So for this topic, I'm going to actually to introduce to in another separate section if people are interested. Okay, so last but not least, and to remember to subscribe to this channel to keep you updated on the latest AI machine learning techniques, trends, and topics. And also you can download a copy of this slide deck and the step-by-step hands-on notebook. The URL link for download is actually showing in this videos, the description, below. And also you can also explore the many more, free, data science ebooks and resources in the same link as well. Okay, thank you everybody, and see you later.